Have you ever wondered why your food spoils faster in the heat? Have you ever wondered why chemical reactions occur faster at higher temperature? Then, Arrhenius equation explains this for us. And in this video, we are going to be taking our time to explain what we mean by Arrhenius equation and the calculations that are involved. I remain Adrenaline, the Bazooka Prophet, BSc, MSc, and PhD in chemistry. And today, we are going to be going deeper on aspects like this. Now, the equation for Arrhenius is given by the rate constant is equal to, now take note, this A here means pre-exponential factor or collision with frequency. The EA stands for activation energy. R is your gas constant, which is 8.31, and T your temperature. So, Arrhenius equation relates the rate constant of a chemical reaction with the temperature. And take note, when the rate of a reaction is doubled, right, it always occurs at 10-degree rise in temperature. Exam question. For those of you taking any exams, take note that for every 10-degree rise in temperature, the rate of a given reaction is doubled. Now, for those of you who want to join my online classes, you can as well send a DM. Knowledge or learning has passed beyond classroom. It is now beyond what you expected. It is now more of online classes. And believe me, when you join us in our classes, there is so much to learn. This is my phone number in which you can use to contact me so we can start our marathon class that will make you a success within the space of a year or 3 months. It depends on you. Now, this is a question here. There's some question you are given 2 rate constant and 2 temperature. It is simple. So what do we do here? Solution. Now, the question says the rate constant for a first order reaction is this. Meaning, for your K1 now, your K1 is given by 3.46 times 10 raised power what? Minus 2 per seconds. And the temperature T1 is given to us to be 298 Kelvin. Now be very careful. There are times whereby you will not be giving your temperature in Kelvin. You'll be giving in degrees Celsius. Always convert to Kelvin by adding 273 to it. Now, because of what is the rate constant, which is your K2 is equal to question mark, what I'm looking at for. And the temperature here, T2, was given to me to be 350 Kelvin. And you are giving your activation energy, EA, to be 50.2 kilojoule per mole, which we need to convert to joule per mole. Remember, it will now be 50.2 times 10 to the power 3 joule per mole. Don't get it twisted. Don't get confused. Kilo is 10 to the power 3. That's why I did it like that. Of course, my arrow is constant. 8.314 joule per mole per Kelvin. Now, I'm to use this formula in getting my answer. So what should I do next? I'm to erase the board to create more space for it. So let us solve it together. Now, it becomes lean. My K2 is what I'm looking at for. My K1 is 3.46 times 10 raised to the power minus 2. My EA was 50.2 times 10 raised to the power 3 over my gas constant R is 8.314. Now, remember, it is T2 minus T1. The T2 is 350 minus 298 over 298 multiplied by 350. If you can do this one here, then that is all. This is how we impute all the value. Now, what will I do in this case? I will resolve everything here. Take note, use your calculator to punch it. First of all, subtract, you have a value, times it by this one, times everything down here, then you divide. When you do so here, you should be having it to be 3.010. That is what I have here. So, I erase. Now, I'm not having it to be log. Okay, sorry, not log, ln. Ln K2 over 3.46 times 10 to the minus 2 is now equal to 3.010. Now, this is where a lot of students will have issues. I want to make only K2 over 3.46 times 10 to the minus 2 to be alone. So I have to remove this ln from here. If you remove ln from here, to remove ln, you take the exponential of both sides. It's your calculator. If you check your calculator now, where you see where you have something like this, ln. You see where you have up here. See where they put e raised to power x. So in your calculator, you are using Casio. Close back to your right in your Casio calculator. So what do you to remove this ln? You take the exponential of both sides. Exponential will remove this ln. So you're not having K2 over 3.46 times 10 raised to power minus 2 is equal to. Now take note. To get for this exponential now, it will now be, you press shift, you press that ln button. So you will now be you press shift, you press the ln button, you'll be having it to be 3.010. Okay. 1, 0. You'll be having it to be what now? 20.29. 20.29. Now, I am looking for my K2 here. So my K2 here, take note. My K2 will now be equal to, yes, now over 1, to be 3.46 times 10 to the minus 2 multiplied by 20.29, which will now be equal to, that's 3.46 exponential minus 2. The final answer is now 0.7019, right? 19, and the units, since it's a first order, is now per seconds. This is the final answer. So this is how the step-by-step processes are for Arrhenius equation, and every other question can be solved with this pattern. Thank you and God bless you.